So we are talking about ground truthing. Ground truthing means we are going to validate. I put in the chat box the link to the previous presentation about the super El Nino that is happening this year. That's why you are experiencing heat wave even in Europe.
Yeah,
right?
I was actually about
So,
to ask if there's any news when it's happening and if there's already something happening and damage done.
okay, I will explain now.
Okay.
I will explain now. Okay.
Yeah.
So climate forecasts provide us with an increasingly accurate picture of the global environmental trend. Today, the scientists can forecast sea surface temperature anomalies, marine heat wave, El Nino, La Nina cycles, and even estimate the probability of coral bleaching events months in advance. Okay. So, however, these forecasts describe what is expected to occur global and regional scale. They do not always tell us precisely what will happen at individual reef systems.
Yeah, how?
Yeah. This is where ground truthing, this topic that we are going to talk about now, this is where ground truthing becomes critically important. Okay. So what is ground truthing? Ground truthing is the process of validating the forecast. The forecast comes from NOAA or from Copernicus marine surveys. They are based on advanced instrumentation installed into satellites in space. Okay. They always send us a forecast, but that forecast may apply or may not apply to certain areas. Okay. This is why ground truthing is important. It is not, if it doesn't happen, say in in Indonesia or in the Philippines, it didn't happen. It does not mean that the forecast is wrong. They did not spend millions of dollars sending satellite to space to tell us a lie. They don't. The instruments are accurate. The science is accurate, but that is a science of a global scale. They give us what is going to happen globally, but not locally. This is where we need to understand what we need to understand. We need to understand local microclimate, the geography, the oceanography, the local microclimate, and even more. So today we are going to dissect this part. Okay. So one of the key reasons for these differences is the influence of microclimate. Although global climate drivers like El Nino, the Southern Oscillation, they call it ENSO, El Nino Southern Oscillation affect entire ocean basin, local geographical and atmospheric process can significantly modify their impact. Like now, Philippines. If I were not injured, I will be in the Philippines now in Bayaca Island, for example. It is in Palawan. If El Nino, the Southern Oscillation, is impacting the world, then the entire world is the same. The answer is no. Why? Because there are shallow oceans, there are deep oceans, there are circulation, there are rain, there are mountains, all will have varying impact. Okay. So particular attention will be given to the Coral Triangle where we are right now, the Philippines, Malaysia, and Indonesia until Papua New Guinea. where complex geography and extensive mountain ranges, frequent cloud formation, rainfall system, rain shadow effect, or deep ocean trenches, and the dynamic ocean circulation patterns often create localized, what we call refugia, or shelter that help moderate the environmental stress or help reduce the environmental stress. This natural process can provide temporary protection against rising sea surface temperature, for example. Now, the difference I will explain in this presentation is what happened in the Coral Triangle. Why is there so many places in the Coral Triangle that is not even impacted by it? Yes, the El Nino, Super El Nino is happening right now. That is why you are feeling the heat in Europe. It's happening right now. But where is the coral bleaching? Where is the devastation on coral reef? Why does Philippines are not affected? Why does Indonesia is not affected? Why does certain part of Malaysia is not affected? And then moderately impacted is some part of Malaysia and Thailand. And then, of course, the southern part of the equator, further south, the Great Barrier Reef, they are impacted. The reason why they call El Nino the southern oscillation is because that oscillation happens beginning in the southern hemisphere. Anything south of the equator is heavily impacted by it, okay? That's not the only reason why it impacts the environment and the coral reef in those areas. There are reasons as well. Now, let's look. Ground truthing is validating. This is the part that when I talk about coral reef and how it recovers and how its resiliency is measured, is why? It's because whenever this forecast is coming from NOAA or from Copernicus, institutional science will immediately go to the reef. They constantly go monitor the reef and monitor the reef and monitor the reef. They can't tell you why. If it happens, they will say, oh, it happens because it's forecast. If it doesn't happen, they can't tell you why. Because the reef is not the answer to this resiliency. The biological resiliency of coral takes time. Yeah. For example, there are 400, maybe 450 species of coral species within the Malaysian waters. When I was young, 20, 30 years ago, 35 years ago, the average sea temperature in Malaysia was 28 degrees. Today, the average is between 29 and 30. Does the coral reef still exist? Absolutely. Then, over a period of time, over long-term exposure, organism will adapt to it. That's biological. But that's not the only reason why they are able to adapt to it. Okay? They adapt to it because there are areas that are really impacted. Example, Philippines and Indonesia. Philippines and Indonesia, they have what they have? They have rain clouds forming always because they have mountains, what we call the rain shadow. You see on the upper right hand. Then they have the cloud formation regularly happening. And then they have the night. At night, they have the land breeze blowing cool air back to the ocean. And then during the day, the warm air, sea breeze, pushing the clouds and moisture towards the rain shadow, the wall that is collecting all the clouds. When clouds collect, above this area, because the mountain, the edges of the mountain sits directly on where the reef are. So when clouds happen, what does it create? It creates shadow, of course. Rain shadow, cloud shadow, it creates that. And then what does it do? On the other side of the cloud, on the top of the cloud, there is a reflection. It reflects back the sunlight into space. Okay? So this is how local microclimate shape the survival of the coral reef during a changing climate. Okay? So almost, I can say almost 80% of the aspects of survival of coral in Indonesia and the Philippines is contributed to the local microclimate cycles. It has nothing to do with, whoa, they have super corals over there. They didn't die during this. No, it's not true. Don't relate something that's biological or make assumption that the coral in Indonesia and in the Philippines and some part of Malaysia are resilient to this. No, they're not. They are actually, they happen to be in the luckiest place a coral reef can be, in the coral triangle. Okay? So this local microclimate, what it does is it regulates temperature extremes, it makes salinity, it controls salinity as well, yeah, moderate rainfall and salinity, driving the ocean nutrients and circulation, create refugia. So the mountains actually save the coral. Because why? Solar geometry. If the reef is on the south, east, and west side of the islands, they get more sun. They probably exposed to more sun, and therefore they are going to get more impact. But in the north, because of the solar geometry, they get less daylight over the other side because of the shadow of the mountain. And therefore, the north side always is safe by extremes. Yeah. And also, if you notice, if you ever go to Asia or the Coral Triangle, go to all the smaller islands, go south, you find plenty of coral. Go east, you find plenty of coral. Go west, you find plenty of coral. Go north, you get less coral, but bigger in size. Why? Because they survived many devastation already over in the north, because they don't get the full impact of whatever is coming. Okay, so south, east, and west get impacted, but we have the land and sea breeze cycle. You have the cloud formation. You have the rain shadow. You have the deep ocean trenches. Yeah, the upwelling here. Okay, deep water trenches upwelling, and then the position of the reef, if north, south, east, west, reef refugia, we call it. The local microclimate help maintain healthier conditions because of its literally its geography, a unique geography, a natural advantage of the coral triangle. It is not that people in the coral triangle are the luckiest and God-given people, they get the coral reef like that. No. Because it is the mountains, the volcanoes, the local microclimate, the deep trenches, the geography, the entire geography of the coral triangle sits in an ideal place where, when there is a climatic change, it will be self-regulating in many ways. Okay? So now I'm going to bring you to another place where the geography is different. So let me take you to the next slide. The Great Barrier Reef. Okay, why is that? This is why the misconception happens, because a lot of reports, because in Australia they are more advanced, there are more researchers. But it is different. Great Barrier Reef is so vast, it spans far out into the ocean, far away from the highlands, that they don't have the advantage of the coral triangle have, the rain shadows, the sea breeze, land breeze, did little to help because it is so vast. The area is too big. The geography at the moment with the climatic changes, this geography is at a disadvantage. Okay? It happens to be unfortunate, right? So we need to understand this. The full exposure to El Nino happened to places like this. Is it only Great Barrier Reef that is going? I will point out some other areas later that has the same thing. So when the geography cannot help, then the coral will have to take full brunt of the climatic change, right? They will have to take, because of limited refugia, the greater risk it is to their coral reef over there. But if you are a coral biologist in Southeast Asia and you start reading reports that is coming from the Great Barrier Reef, then you should go back to school, right? You should go back to school because that is not the way you want to look at resiliency. Okay, if you want to look at resiliency on the basis of biology, then you need to learn about the evolution. You need to learn about the climate, what climate has changed during that period of the evolution. Then you come to some sort of conclusion why certain areas there is. Like, for example, the Red Sea. For example, the Red Sea is far from what is happening over here. And their reef, most of the time, are resilient. There is other reasons for that too. Okay, so this is the example. Having examined this on how the coral triangle benefit from the complexity of the geography and localized climate regulation, it is equally important to understand regions where these natural buffering mechanisms are less pronounced. The Great Barrier Reef is the largest reef ecosystem on Earth, extending more than 2,300 kilometers, and it is sitting along the northeastern coastline facing east, and it's all extraordinary natural system, but it is exposed to what the climate is bringing right now. Okay, one of the major differences is the location of Australia's mountain range. While substantial highland exists, much of the elevated terrain is located inland and does not interact with coastal reef ecosystem in the same way the mountainous islands do in Indonesia and Philippines. As a result, there is less topographic influence on cloud formation, on rainfall concentration, on rain shadow development, and localized coastal climate regulation directly above many reef areas here in Australia, for example. Okay, so then let's look at Gulf of Thailand. and the South China Sea side of Peninsular Malaysia. They have the similar impact of what Great Barrier Reef have, but they have another thing that help regulates, okay? They are shallow ocean and their water temperature rise very quickly. You know, when the volume of water is less, the temperature can rise quickly. It can drop quickly too. Salinity, everything can change quickly, okay? So, but it also have mountain ranges that is far inland. It doesn't benefit that much from the sea and land breeze circulation. Mainland coastline dominate the land, and the sea breeze and land breeze felt along just the coastline, yeah, the coastline areas. They don't reach the outer islands, okay? So therefore, when they get heat waves, when they get heat wave, they're really burning hot during the day, okay? So, but they're slightly different because of it's shallow. So what do you do when you put a heating lamp over a tray of water, shallow water? It evaporates quickly, right? Yes, it does not have rain clouds that is collected along that mountainous area, but it always have clouds. If you go to islands along the peninsula of Malaysia, they rarely have blue sky. They always have a lot of clouds. Why? Because of evaporation. And that clouds actually save most of the reef there because it bounces back the heat radiation, heat and the radiation of the sun back to space, okay? And it also helps with regulating the humidity. They will have high humidity, but when there is even small amount of wind, moist air is cooler. So their low-lying island did not provide rain clouds, but their shallow ocean creates clouds anyway above it, okay? So they are slightly different. If they did not benefit from this evaporation and cloud formation, they will be having the same impact as the Great Barrier Reef, for sure. That's for sure, okay? So the lack of height, they did not generate the microclimate like the orographic clouds or rainfall clouds directly above the island. And the orographic clouds happens in the inland mountain ranges far away from the coast, okay? So, but because of rapid cloud formation over shallow seas, they get shade. They get shade. This is why a lot of people who dive in Southeast Asia, they fly from Europe, from America, they fly to Southeast Asia and they go diving and they see all this beautiful coral reef in Palawan, in Raja Ampat, in Togian Island, in Wakatobi, in the Borneo. They still see a lot of living beautiful corals. And then when it comes to forecast, like, oh, it's gonna be reaching the tipping point, it's gonna be dead, these people will start to ignore because they think that all this forecast is a hoax, it's a lie. It's actually not a lie. They tell you the truth. It is happening, but because there are local microclimates that regulate this, therefore there still exists many parts of the coral triangle, there still exists healthy coral reef. It is not reaching the tipping point yet. So if you talk to a diver who dived for 40, 50 years or 30 years, they say, yeah, I heard about it like 25 years ago or 30 years ago. I heard it now. Where is it? I didn't see any. You know, where is the tipping point? Well, is all the fish dead in the ocean? Nope. So these people will begin to think that the scientist is crying wolf. When you cry wolf for too long, and people will start to ignore you, right? This is why we have to be careful at reporting climatic changes and its impact on the coral reef, or else why does coral reef restoration programs did not get as much funding as other programs, since coral reef is one of the important ecosystem on Earth? It's because of this reason. Because those people, the policymakers, they go on holiday. They go to places where the coral is pristine. They go to the Coral Triangle region, where the local microclimate is providing refuge to the coral. They go, and when they saw this, and you bring it to United Nations in Paris and say, oh, the coral reef is reaching tipping point in this, they just come back from holiday. They just saw a reef full of corals. What are you talking about? This is why we need ground truthing. Ground truthing is validating and providing an accurate report on what is happening to the coral reef around the world. Okay? So, bridging between the global focus and local realities. We need to understand this. The global focus is the big picture. We need to understand the big picture. We need to know that the Earth is inching towards the sun over a period of time. We are getting warmer and warmer. It's not getting cooler. But organisms on Earth that has evolved for millions of years has their own way. The geography has their own way. Why does coral reef choose to be in the Coral Triangle in the first place? We didn't know, but maybe it's the geography, right? So then we need also to know the reality that the local microclimate matters. We need to know in many parts of the Coral Triangle reef are healthy and thriving. In other areas, the stressor leads to bleaching and decline. There are decline, of course, undeniable. There are places even in the Philippines that decline, but out of other factors than the heat wave. Okay? Why? Because there are other factors that the tropical storm, for example, the ocean acidification, I did not include in this part. I include this part only about the climate and the climate reports and the climate global forecast. Okay? So the human mismanagement, you know what the biggest threat to coral reef in the world is politics and bureaucracy. That's it. Because people who are assigned to manage marine protected areas sometimes did not even know anything about corals at all, right? So they are assigned politically. In that sense, it doesn't help to protect an environment when the inhabitant knows nothing about it, okay? And then it does not cover extreme marine heat waves like the 2024 spike of marine heat wave, right? And then disease and other local disturbances we don't include yet. So combined, this can be a threat to coral reef for sure. Climate alone did not do most of the damage. It's a combination of factors that makes the decline of coral reef. So don't stand on the box and blame the climate just solely because it is a popular topic about reef decline today. Climate is not all of it. The other part is the storm, the ocean acidification, the mismanagement, the extreme spike of heat waves, disease, and other local disturbances. That includes unregulated tourism, whatever you want to call it. Okay. So now that we understand, we need the forecast. We need to listen to the forecast to know what is going on in a big picture, the global forecast. We need that. They didn't lie to us. They are giving us accurate report, but we need to validate them through ground truthing so that we understand where we are and why certain things happen in certain ways in local areas. Then once we validate them, and this will work together, will bring everyone together in an understanding on how to have a positive strategy to take action. Okay? So, right. That's a short presentation. Hi, everyone. So, question? Any question?
Actually,
Hi, Anwar.
Hi.
sorry.
Okay. Yeah. I'm listening.
Who's going to be first?
Yeah.
Actually, it covered almost all the questions I had in my mind.
Yeah.
El Nino and how it will affect, where it will affect, and how we can collect information where the damage has happened, and also thinking about who is gonna who is going to look at the reefs and who is going to collect the information about the damages.
Okay.
Because
Okay. The
yeah.
reason why I started Ocean Quest Global, for example, my previous organization, Ocean Quest Global, is because of this, because of global data. I have the most comprehensive global data because I operate about 84 locations around the world. And I saw all these differences. Undeniably, there are locations that is degrading, okay? Repeatedly degrading. And to a point that we think that it's not going to recover. But things change. Some places that is degraded a lot, almost entirety, but they recover after 15, 20 years. But there's the problem. A lot of researchers did not stay for 15, 20, 30, 40 years like me, right? So they did not stay long enough to be able to interpret what is going on. So when you take all this factor out of the coral resiliency equation, then the biological side of how the coral adapt to the local climate is actually a small factor, right? So it is not a big factor. We cannot design a gene, a coral gene that will be resilient to climate. No, no. The coral that exists 10,000 years ago, probably still the same species survive until today. How many degrees have the ambient temperature rise from that time to today? And those are gradual exposure. And with gradual exposure, there will come an evolution. They will evolve to adapt to it. Okay. Men, you know who's the best people who can save the coral reef of the world? It's nobody. If human is taken off the coral reef, like during the pandemic period for 2 years, the reef bounced back like nobody can imagine, right? So The best people who can fix the coral reef is no people. That's about it. Right? That's about it. But we can do our part to help conserve in smaller areas where we think that we can contribute. But the intervention has to be careful. We can help speed up the process of reef recovery by transplanting, by propagating. We can help speed up the process. But if they want to die at any moment, we have no control over it, right? If they want to thrive, then it will be all over the social media for sure. Right? Okay, this is the truth about coral reef. I'm teaching people coral biology so that people understand the biology, the behavior, the ecology of coral, and how they adapt to their environment and everything. The more we learn about it, the more we are afraid to touch it. Because why? Because we know that our hand is the most toxic thing in the world. Anything that human touch will eventually die. That's it, right? That's the truth about it. So we need to understand that. But in this presentation, we are talking about climate. I maybe make the ocean acidification part. I maybe make about human pressures on coral reef, right? So I maybe make that, but I need to go out and I need to video, I need to take pictures to have data to support what I'm saying, okay? Then that takes time. So, question, Songgul? Anybody? Question?
So I just typed one.
Yeah, Stephanie.
What you were explaining kind of led into my question. I had read somewhere that the same species of corals in different locations may be more tolerant. So, for example, an acro species in the Red Sea may be more tolerant than the ones in, or the same species in the Coral Triangle.
Yes. Okay, look at it this way. Acropora florida, for example, yeah? Acropora florida occurs in the Great Barrier Reef. It occurs in the Coral Triangle. It occurs in the Andaman Sea. It occurs in the Indian Ocean. It occurs in the Red Sea, okay? And then the Acropora florida in Australia lives in water that is 26, 27 average. When it gets to 29 degrees, they bleach. Okay. That same species in the Coral Triangle lives in 29 to 30 degrees average. It needs to be 31.5 to 32 degrees before it bleach. Okay. And then the one in Thailand, for example, are very similar to the Coral Triangle because the water temperature is more or less the same. And then in the Red Sea, Acropora florida that occurs in the Red Sea never bleach, right? And they have no rain clouds. Their sky is blue all the time. I was not talking about that earlier, right? The sky is blue all the time. The ambient temperature sometimes reach 51 degrees, right? And the water temperature, why does the Red Sea water temperature remains like 28? And then in the wintertime, it can be 18, you know. In the summertime, it can be up to 30 degrees. Does the coral survive? Absolutely. In the Red Sea, the coral survive wintertime because the Red Sea, especially in Hurghada area, they are not even tropical. They are subtropical area where they have winter, right? And when we study coral in Southeast Asia, we said that anything below 22 degrees, the coral will die. What about the one in Red Sea? 18 degrees, they're happily ever after. What is happening, right? So we cannot compare. This is why if we read articles or we read scientific papers that is written in the Great Barrier Reef and we try to apply it in Coral Triangle, don't do that, because it is entirely different geography, okay? And you might have a lot of errors, okay? So that's the reason. So yeah, I read your chat already, Stephanie. So when we want to study coral, if we want to study coral in Red Sea, remain in Red Sea, study it until you finish. If you want to study in Coral Triangle, remain in Coral Triangle, study it until you finish. Because if you go from place to place like I do in the beginning that I didn't know, I've been moving around, I've been going to Red Sea, I've been going to the Pacific side, Fiji, Vanuatu, I've been going to all this Coral Triangle, and I was completely confused, right? Then I realized it's not the biology of coral, it is the geography that also influence a lot of its survival. Okay?
Anwar, can I ask a question also?
Yeah.
Therese, Anwar, what happens like when the lightning hits the water? For example, like what happened in the island in Tambon and in between Tambon and Tampil, and then the lightning hit the water, and the depth of that area is shallow, like it's shallow, and then what happens there when there's a lightning? Actually, because the lightning, of course, is strong, right? So how does it affect the corals? Nothing.
Nothing. Because the seawater grounds it. The water is a ground. That is why, example, when someone was drifting in the ocean and a rescue helicopter comes to rescue that person, and they will drop a wire. They drop a wire until it touches the sea to ground, because the static electricity that is on the cable, right? If they don't ground it, they will electrocute the people, the rescuer that is going down, or they will electrocute the people is coming up. So it needs, as soon as the wire touches the sea, it grounds and it don't cause the electrocution. Lightning is the same. It hits the surface of the sea and it disperses. The sea is a lightning dispersal already. So the question is regarding the bottom trawling, mass washing of coral due to it. Yeah, that is human destruction, right? So the problem is bottom trawling or deep sea fishing or whatever you want to call it, it's a business. When it's a business, it didn't care much about what is destroying. Besides, whatever is under the ocean, nobody's on the trawler boat will see. They only see when they troll it up. So that is human pressure. That is the part of destructive fishing that everybody turn a blind eye about. Because why? Most of the trawler companies, whatever, is only all political connected. They cannot be stopped for sure. But slowly, with pressure, they will regulate them, regulations. They cannot stop entirely for sure, but there must be regulation. Yeah. Yeah, Magu. Magu is raising a hand.
Hi,
Hi.
Anwar. Can you hear me?
Yeah.
Okay. So I was wondering about I guess in context to the Philippines, because since I guess we're not as affected right now with the heat compared to other countries, but in terms of tourism, it's people from those countries um, looking to migrate here in the Philippines or
Mm-hmm.
else, yeah, in the Coral Triangle area. So I would imagine that's like increased pressure as well in some forms.
Yeah,
Um,
I think Philippines is one of the most blessed country in the world. They have coral reef, they have mountains, they have beautiful islands, they have everything. They have people who smile nonstop. They have everything, okay? And that attracts other people to come and want to live there and do things there, things like that. It is not about just the population increase. It's about the consumption, right? Because of the huge population and more input of people coming in. And industry, for example, is growing now. Tourism is growing. Definitely few million people a year is coming to Philippines. To add up to waste that is flowing down into the ocean from hotels, uh, more demand for seafood that is going to be illegally caught and stuff like that. Um, more unregulated tourism that's breaking the reef and stuff like that. A lot of things will happen. Okay. I'll give you an example. In Borneo, for example, before the pandemic in Borneo, the tourism operators, especially the people who work in the tourism, the boat captains and the boat crews, they are beginning to get arrogant because they think they are the people who are needed to get the industry going, right? So they don't care. They take 100 people, 200 people. They don't care about stepping on coral. Then the pandemic came. When the pandemic came, I get a feedback from one of the boat drivers who used to be a fisherman before. So he tried to go back to his old way and go to the reef. That is when he regretted. He regretted because the Chinese people from China or the Korean, the Japanese, the European that he bring to the coral reef that snorkel and snap and broke his reef is not coming anymore because it's pandemic and that broken reef has less fish now. And he start to realize, oh, this is the impact of what I have been doing for many, many years. And now I realize it, that there is less fish to catch when my family is hungry. Will we, human beings, get to that point? Yes, if we continue at this rate of ignorance. No, if we improve ourselves to get better blue economy concept or more conservative practices, regulate ourselves, make policies that actually make sense, then we will go in a better direction. If we continue, we will go to this point of Henry. His name is Henry, the guy who told me that there's no fish to catch now. Then we will get to that point. When we reach a point where tourism no longer feasible, when things are depleted, when minerals are mined from the ocean and destroyed, when destroy everything, then we are going to reach the dead end. So the conservation that I'm talking about has nothing to do with corals, has nothing to do with the turtles, has nothing to do with the dugong. Turtles, dugong, coral did not come to my whiteboard and write the word conservation. humans needs conservation for the survival of the human species, right? This is the truth. I did not work on coral because I think that the coral is going to thrive and I'm going to be famous or whatever. No, I don't even see the result of my work when I die because it takes so long, right? But who is it for? Is it for the coral? No, for the future of my children, their children, your children, their grandchildren. That's it. That's what we do for the world. That's why I'm doing this in, year out, without thinking about what the hell I'm getting into, right? Why am I doing this? So this is why. If we have the conscience, we have the ability to think beyond the facade of it, then we are able to decipher the messages of what nature has given us, what God has given us, how blessed we are to be alive at this time of the epoch of human, right? So we are actually still blessed. We still have the time. It's not at the tipping point yet. Forget about those reports and tell them to go back to school, right? Because we are able to change things if we want to, and if we focus on it. One person tells 10 others, 10 others tell another 10, and that's how it spread, this message. Right.